Hello, this is Mrs. Freeman at Central Virginia Christian School, and this is our virtual science fair. So, welcome to the fourth grade second annual science fair, and we're going to start off over here with Sammy Ranson. So, the question was, what's the favorite dog toy? We've got some pictures here. All right, and he thinks that Toby's going to choose the plastic bottle. That was his hypothesis. He has his research, his procedure. Here's the graph. This is showing the different toys and how many times in minutes that he played with it. Here's the results. He picked the bottle first every time and had lots of fun. The conclusion was the plastic bottle is best, which supported his hypothesis. Very good, Sammy. Next is Jacob Johnson, and his question was, how long does it take a crystal to crystallize? He has some good pictures here of the process. This is what they ended up looking like. His hypothesis was that it would take 48 hours. And here's his keywords and research there. Some big words. His procedure. Results. He has week 1, week 2, week 3, and week 4, and how many crystals there were over that time period. The results were it took a month for them to form, and some did not form. So his process, his project question was that it took 4 weeks to form, which was not his hypothesis. And he said he would improve it next time by using less sugar, more food coloring, and a little bit more flavoring. Next is Ethan Holland's Mentos reactions, and he tested ginger ale, Coke, and sparkling water. Here's the sparkling water. Those are the 3 choices. Ginger ale. Right, he thought that it would fizz the most with ginger ale, almost explode with Coke, and barely fizz in sparkling water. Here's his graph. And the amount of fizz for Coke, pretty good. Fizzed a lot with sparkling water and bubbled a little with ginger ale. The results, we had 12 ounces of sparkling water and 1 Mentos and fizzed everywhere. The same amount of Coke and it fizzed everywhere too, and ginger ale and it did not fizz. So his conclusion was sparkling water had the best reaction, and these were different from his hypothesis. Next is Carter Jackson. How many marbles will it take to sink the Lego Titanic? So he had fun building a Titanic first, and then adding marbles to see what would finally sink it. Here's his hypothesis and keywords and research. Here's his graph. So it shows how many marbles he put in and how many it took to sink it. And then he has some real pictures of the actual Titanic. Very good. All right, next is Austin. How much water does it take for a plant to grow? So he thought that it couldn't have too much water and that you couldn't use too little water. So you had to have just the right amount. Keywords and research, procedure and materials. Good artwork here. And his graph is measured in the cups that it took over the amount of days. So he took 5 days for his project, and each day he would test the soil and see if it was still wet. That's how he would perform his experiment. His conclusion was it took 5 cups of water for the plant to grow, and the results supported his hypothesis. Very good job. Next we have Grant Gillum, and this is the grocery store and the bacteria that you find there. So he has unwashed hands tested, clean hands, bathroom toilet seat, clean hands with soap and water, the freezer door handles, and the shopping carts. All right, so his hypothesis was the bread touched by clean hands will have the least amount of bacteria, and he thought the fridge handles would have the most bacterial growth. He's got his procedure and materials there. Here's his graph. And he has different explanations of what's happened with each of the pieces of bread, and what was happening at week 1, week 2, week 3, and week 4. Then he made some pie graphs over here. Results and conclusion. There was very little mold to grow after the 4 weeks. The only piece of bread that actually grew mold was the bread wiped on shopping carts. Shopping carts are the dirtiest thing in the grocery store that they tested. Good job. This is Jacob Freeman. Do light cars go faster than heavy cars? His hypothesis, he thinks the lighter car will go faster. Keywords, materials and procedures. Here's his pictures of the finish line and the ramp. And here's his data. For trial 1, trial 2, and trial 3, he measured how fast the car went and how fast the car with the weight went. His results, hard to keep the car in a straight line with the weight, and the car with the weight went slower. And that was his conclusion, that his hypothesis was right. The lighter car went faster. Next is Skylar Salisbury's What's Popping? So hers was which brand will be the better brand of popcorn, and she predicts Pop Secret will be better. And then she's got her keywords and research here, materials, procedure. Here's her graph. And these are the 3 types of popcorn that she tested, and how many kernels were left with best tasting. Some good examples here. Her conclusion was that Orville Redenbacher won as best tasting. Act 2 won for the highest percentage of popped kernels. Her results did not support her hypothesis on the most percentage of popped kernels, but did support on the best tasting. And there's her results. The Orville Redenbacher brand smelled delightful and looked good too. Pop Secret had the most smell to it, and Act 2 smelled burnt, even though it wasn't. Very interesting. Next, we have Sierra Petersheim. How many potatoes do you need to power a light bulb? Called Veggie Power. Her hypothesis was it would take 3 potatoes to light an LED bulb and make the buzzer work. Here's her keywords and research. Procedure and materials. Here's her pictures. That's all that she used there, putting it together, powering the LED bulb and buzzer. Here's her graphs. Here's potatoes, using 1 potato in the voltage, 2 potatoes, 3 potatoes. Here's her results. That the 2 potatoes did light up the bulb and powered the buzzer, but the bulb was dim and the buzzer was quiet, but that 3 potatoes lit the bulb up and powered the buzzer. So her conclusion was that it took 3 potatoes to properly light the LED bulb and make the buzzer work properly. And that's what she said in her hypothesis. Next is Daniel Meeks, a battery that makes sense. So he thinks it will take 10 pennies to get 1.06 volts. But it looks like it took 4 nickels and 4 pennies. Keywords and research, procedures, materials. Here's his picture. He's got some pennies there. Using the voltmeter, measuring the pennies. Here's his graph, and it shows 1 coin, 2 coins, 3 coins, and 4 coins, and how many volts were produced. Results were it took 4 pennies and 4 nickels to make it work. His conclusion, he would improve it by making it larger. Okay, next we have Nina Davis. This is what conditions keep a banana yellow? Her hypothesis was the banana in the refrigerator would last the longest. Keywords and research, procedure and materials. And here's her pictures. She's got in the pantry, on the counter, and in the refrigerator. So you can see the difference there, looking at 326.20. And here's her graph. So on 312, they started out the same, 319, and 326. And the refrigerator is the yellow bar, the counter is the pink bar, and the pantry is the green bar of where they were ripened. So in the refrigerator, the banana quickly ripened and turned brown, then black. The one on the counter had a slower change. The one in the pantry stayed yellow the longest. So her conclusion was the pantry was the best place for a banana to be stored if you want it to stay yellow. Next, we have Hunter Giffen. This is what to drink. His question is, which flavored drink has the most sugar? All right, and his hypothesis is he thinks Bang has the least sugar and it's healthier, and that Mountain Dew has the most sugar. So it looks like he's taste testing, using 5 people, and how they compared that, and then boiling it for 5 minutes, and the results of what was left. So you've got Mountain Dew, you can see the amount of sugar there. Wild Cherry Pepsi, Dr. Pepper, Coca-Cola, Sprite, and Bang. Materials. And his conclusion. There's a lot of sugar in flavored drinks, is what he learned. And that if a person drank 4 flavored drinks, like Pepsi, in a day, they would consume a cup of sugar. Energy drinks don't have sugar, but has a lot of caffeine, and not recommended for kids under 18. So Mountain Dew has the most sugar and Sprite has the least, but really none of these drinks are healthy. So stay drinking water. Thank you, Hunter. Next we have Bryce Whaley. This is how tall can the skyscraper be before it falls? His hypothesis, he thinks a very tall skyscraper will likely fall from a typical earthquake, and a typical skyscraper will likely fall from a massive earthquake. Keywords and research, procedure and materials. And here are his photos, building a platform, the skyscraper getting taller, simulating an earthquake, and the fallen skyscraper. His graphs and data. Here he measures how tall the tower is with an earthquake, and looks like nothing happened up to 5.75 inches or 15 levels. Nothing happened moving the earthquake up to 2.5 inches, but that a 3-inch earthquake, moving it back and forth that much at 20 levels, that one fell and broke. 25 levels fell and broke starting at 2-inch earthquakes. And the 11th tower that was 11.25 inches tall broke at 30 levels at 2 inches. His results, the Lego skyscraper, 15 levels high, was tested. This was like an earthquake, and he shook it in those inch intervals, and the 1/2 inch was a small earthquake, the 3-inch was a big one. Skyscraper did not fall under any size earthquake. But then he built the height taller to 20 levels, and then higher again to 25, and then higher again to 30, and it broke at the 2-inch shift. His conclusion, that a skyscraper would withstand a small to big earthquake at 15 level height. At 20 level would fall after a big earthquake. 25 and 30 would fall at a medium earthquake. The height of a skyscraper matters a lot as how it stands up in an earthquake. And then he's got some pictures here. Good job, Bryce. Next, we have Brianna. This is, which liquid will make the gummy bear grow bigger? She thinks that baking soda will make the gummy bear get bigger because when you use it for baking, it makes things get bigger. Keywords and research. Procedure and materials. Here she's got salt water before and after, some pictures. Water before and after, you can see the change there. Baking soda, you can see the change there. And vinegar. Down here is her graph, comparing water, salt water, vinegar, and baking soda. And then she measured how big the gummy bear was before and after. Here are her results. She tested them 2 times and did her experiment with baking soda, salt, vinegar, and water. And the second time she used all the ingredients, 1 teaspoon of those. Her conclusion, which liquid makes the gummy bear grow bigger, was the vinegar water. She thought it would be baking soda. She said she was wrong because the vinegar water was the biggest when the gummy bear came out. She would change her experiment by not using regular tap water, but using flavored water. Thanks, Brianna. Next, we have Anna Reams, which popcorn pops the best. Her hypothesis is that since the popcorns came from all different factories, there will be different outcomes and different number of kernels left. Here's her procedure and materials. She uses 4 brands of popcorn and then measures the number of kernels left over using Orville Redenbacher's Act 2, Movie Theater, and Trail's End. And here's her graph. So the number of unpopped kernels in each test. So she popped them twice and counted the kernels, and then she has an average. And you see which one has the most would be Act 2. And looks like the Boy Scout brand and Clover Valley are tied at 44 average. Research, variables, her results. She's got the Boy Scout brand, Act 2, Orville Redenbacher's, and Clover Valley, and those measurements in the graph. Her conclusion: some bags of microwave popcorn had less kernels than others, even though the bags were fully popped when removed from the microwave. Very neat. Next, we have Delilah Vaughn, which slime is the best. Her hypothesis is that basic slime will be the best, using that recipe. Her keywords and research, procedures and materials. Here she has her pictures. Looks like she has 3 different recipes that she tested. Made some cool shapes out of those and CVCS. Here's her graph. So the bubble is the white one. The InstaSwirl is the pink one. And then she stretched them, it looks like, to test. These are the different ways that she tested. So her results: pink slime was the best slime. The pink slime passed the click, stretch, and InstaSwirl test. The white and pink slime could not make a swirl, click, or stretch. The cupcake slime passed no test. The white slime made a bubble. So this pink slime is the one that passed all the tests. And then she's saying the white slime couldn't make the swirl, click, or stretch, and the cupcake kind didn't pass any of her tests. Her conclusion: the pink basic slime passed most of the tests and is the best slime out of the 3. And that was what she thought in her hypothesis. Very good. Next is Deborah Zhang, and this is rainbow liquids. Will the honey hold the colors in the glass? Her hypothesis: got an interactive board. Lift the flap. Yes, the honey is heavy and can hold all the colors, and the honey is very dense. And then she's got her words, key terms, and these are her procedures. All right, so she's testing honey and dish soap, water, olive oil, and rubbing alcohol to see which one holds the colors the best. Here she made some drawings. This is showing all of the liquids in the glass. You've got rubbing alcohol on the bottom, olive oil, green water, blue dish soap, and honey. And then to make the liquid, using food dye and different colors. You get the rainbow liquid. So this is showing which color sunk to the bottom based on which liquid was in there. So rubbing alcohol at the bottom, olive oil, water, dish soap, and honey. So the honey held all the colors, and the rubbing alcohol mixed all the colors. Her conclusion, yes, the honey held all the colors in the glass, which supported her hypothesis. Very neat and colorful. Last, we have William Hoggs. This is, how much weight does it take to break an egg? His hypothesis was that it would take 30 pounds to break the egg when it was facing up and 5 pounds when it's facing down because of its shape. Materials, large white eggs, water, plastic bucket. Keywords and research. And procedures. So here's his pictures. So he's got some wood here. And he's got his egg in between the wood. Putting the bucket on top of the wood and then measuring how much weight in terms of water it will take to break the egg. There's the egg broken. All right, let's see which weight was it? So here's his trials, the first, second, and third, and then in pounds. So it's like he's got vertical means the egg is upright, horizontal is laying on its side, and the blue line shows when it's sitting up straight at 8 pounds and 6 pounds and then 10 pounds. The average was around 9 pounds, it looks like, 8.5 to break it. And then horizontal, laying on its side, 10 pounds, 11 pounds, 9 pounds, and then the average was around 10.5 pounds. His results: tested the first 3 eggs in that vertical position and repeated it with them in the horizontal position. The horizontal average was 11 pounds. Instead of a 25-pound difference, there was only a 3-pound difference in weight that it took to break the egg. So his hypothesis was a little off because the egg could take more weight horizontally than it could vertically. And here he has his conclusions. And the average vertically was 8 pounds to break it. And then horizontally, the average was 11 pounds. Very neat. So that was our 4th grade science fair. I hope you enjoyed it. If you want to know more details, please let me know. I'll be taking emails, any questions. Thank you all, 4th grade. You did awesome. I'm so proud of you.